Hey guys, Mr. Dr. Logic here. I have a few midterms that I needed to do, and this was in my top priority. Understandably slow. I'm making this really late, but hopefully this video is not to give you guys answers, but to clear up any confusion. And despite some of the answers being confusing, I might have BS some parts, but that's just me. Anyway, moving on. Basically, if you look up any image of DNA conservation, the parent DNA, if it replicates, basically the whole thing remains. Semi-conservative, it splits into two. Disperse, you're cutting it into bits and pieces. Continuous means it's like one continuous strand, while discontinuous means you've sectioned it off. This is the answer for 2A. Basically, this was to prove, this was essentially to, what? These were the three prevailing theories back in like the 90s. But people leaned to this until they broke through with this experiment, having conservative, and that's how it was proven through E. coli, I believe. This whole segment came straight out of Smart Bio. Pretty simple, straightforward. Binds to this. Called primers. Basically, they are helpful for DNA synthesis. And DNA polymerase. This is the point: replication, repair, and sometimes cell differentiation. Number 5 was the hardest and pretty much the most trickiest, in my opinion. Okay, this is what I believe for DNA. This is what I think for RNA. The numbers, don't ask where they came from. This is the error rate. And I want to say thank you to some of you folks that helped me unknowingly. It really means a lot. Because some of these I didn't know the answer to myself. Think of this as a collective community effort. These are the answers for all of these. If there's something supposed to be here below, I have no clue. Okay, it's very tightly folded. What is the effect? It doesn't really have an effect on DNA replication. It just makes it harder. Because you gotta unwind it and then start replicating it. That's why we need the fork and all that. Question 7 is a little confusing, basically because it involves a little bit of math. And it's unclear about that, so I don't blame any of you for not getting it. So basically what you need to know is that the fork moves 100 things per second. This is the answer, by the way. This is the answer, okay? 100 per second, and then RPM, which is rotation per minute. So that's what threw people off. All you needed to know was that you had to take, you had to know that this was moving, which was given to you, travels along this much according to bDNA, divided by each other, you get 10 revolutions per second. And then you would multiply it by 60 to get it to per minute. Number 8, basically, what was the question again? Some errors. Checking is done after the span has been replicated. Oh, basically, because a mismatch is detected in newly synthesized DNA, it's able to tell right away between the new strand and the old strand by comparing it to each other. For this one, DNA polymerase 3, the primer, the RNA primer might have just put it in there because we think that it's obvious to us, like it's ATCG, but to these guys it's not, because all they care about sometimes is the bonding. And sometimes if the two bond, that's good enough for them. It's still a miracle. Like, I don't even know how you can correct this. 10, why is the needed? Basically, it's needed for growing the fork movement and the untangling. I need to untangle my voice as well. And then this image pretty much disappeared. I basically copy pasted this. I got so lazy. These two are the same. Just said fuck it. This image already covers all of it, but yeah, I hope that's it.